Today's presentation, I would be sharing my insights and knowledge on digital forensics and OSINT. So, myself, I'm Guransh Singh Keer, and I have insights in web application, ethical hacking, web application penetration testing, and vulnerability assessment and penetration testing, malware analysis, network security, digital forensics, and OSINT. Also, I've been a speaker at various educational institutes promoting cyber security, cyber safety, and cyber awareness among students. We are present in this meeting have witnessed COVID-19 pandemic, and we have also seen how cases were rising up rapidly, and the waves and variants are rising even now. Along with COVID-19, there were many other crises that were rising up rapidly. Anybody would like to share like which crises were rising up during COVID-19 pandemic? You can unmute and answer.
What did you ask, Guransh?
During COVID-19 pandemic, along with COVID-19 and its variants and waves, what were the other things that were also rising up?
Cyber attacks.
Exactly. And do you have any idea like by how many percentage cyber crimes and cyber attacks have risen in India?
Maybe around 153%.
Okay. Anyone else wanna try?
Pardon, please.
Anybody else wanna try? Okay, so there was a rise up to 400% in cyber crimes that took place in India since March 2020. Cybercrimes usually take place using digital assets and digital from digital assets I can say a computer. A computer is a digital asset, a laptop is a digital asset, a router is a digital asset, a smartwatch is a digital asset, our smartphones are a digital assets. And today's computers and smartphones and routers have the ability to store some crucial information that we can that can help us to get a case solved and help us to end a case easily. So an attacker nowadays is well known. Like how do we recover data? So he might try to delete data using those anti-forensic techniques like VPN, proxy chains, and some disk cleanup tools like in disk eraser. If you use such tools, then it's hard to recover data. So that's where digital forensics come into picture, and we need to perform digital forensics on such devices and try to recover as much crucial data as we can. Talking about digital forensics, it's usually a four-step process, starting with seizure, followed by acquisition, analysis, and reporting. In the first stage, that's seizure, we have to seize the device that we found, any digital asset that we found on any crime scene. After seizing the device, we can directly perform any forensic investigation on that because we need to maintain the integrity of the device and from start to the end of the case, and we need to report it in the court. So in second phase, that's acquisition. We try to create bit-to-bit images of the device that we have seized. And in third step, that's analysis. We try to carve information from the bit-to-bit image that we have created of the actual forensic disk or memory. Because of this, the actual data of the memory won't get disturbed or manipulated, and we can perform digital forensics without any problem or difficulty. After analyzing the data, we'll create a proper report that we have to submit in court. The report must include a methodology, tools, description about the tools, and explanation about the things that we have gathered. And then we have to conclude our report. Talking about types of digital forensics, there are many various types of digital forensics like computer forensics, mobile phone forensics, network forensics, database forensics, malware forensics, cloud forensics, IoT forensics, drone forensics, and there are many other fields in forensics that are coming up nowadays. For today's session, I will be mainly focusing on computer forensics. You can see a flow chart of computer forensics. We have two types of computer or top categories in computer forensics. One is volatile memory, another one is non-volatile memory. We can say volatile memory is a memory that erases erases its data every time you reboot a system. It can store a memory after rebooting. And talking about non-volatile memory, it's a memory storage that can store our data for a long time till the time we don't delete it. For example, we can take for non-volatile memory as hard drives, HDD storages, SSD storages, pen drives, flash drives, and any other storage device that is used to store data. And for volatile memory, we can take an example of RAM and cache. Tools to capture volatile memory, FTK Imager, Magnet, Redline, Dumptic, Belkasoft, and many more tools are available in open source as well as paid, paid tools. There is a very famous volatility framework that we usually use while performing volatile memory forensics and analysis. Coming to capturing and recovering data from non-volatile memory, we have autopsy, FTK Imager, NCase, Recuva, and a very famous distribution of Linux called Kane. There are various distributions that's available on internet like Sans or even Sans provider with a Linux distribution to perform various forensic practices, and it already has a lot of pre-installed tools in it. Talking about order of volatile, in forensics we have a volatility order that we need to follow. On the top we have CPU, register, and system cache, followed by routing table, ARP cache, process table, kernel statistics. Then is RAM memory. Then is temporary file system, which we also call as temp files and percentage temp files, followed by a virtual memory that's called as page file.sys. In virtual memory, or we can get increased RAM of a system. It's present in a SSD or HSD storage, or that acts as a swapping machine. And whenever PC is trying to run out of RAM or RAM is trying to get full, this memory comes in picture. It's as an extended RAM for our system. So in this file, we can get a lot of RAM and crucial information. Then is the hard drives and any other storage device that we use to store data. Then remote logins and monitoring systems common picture. And second last is physical configuration and network topology. In this, again, there are order of volatility order and network topology, and it has its statistics and system according to that. Last is backup and printouts. That's a hard copy or any local storage backup that we take. Important things that we can look for in a computer during forensics are event logs. We can view that using event viewer. We can capture a lot of crucial information like what events took place in a computer and what time they took place. Then we can look for is registry logs. We can search for HIFs. HIFs is a directory that it's a file directory present in of HIFs. We can analyze the data present in those directories, and we can get a lot of crucial information from that too. Web server logs, cache, network logs, page file.sys, .sam file. In .sam file, we can get a hash value of our passwords, which we can easily use to get in a system if you have this hash value. Then is dollar recycle.bin. In dollar recycle.bin, we have two categories like $R and $I. In $R, we can get all the deleted data. That's the actual data that got deleted from our system. And in $I, we can get all the metadata of the data that got deleted from the system. In HSD, and we have two parts known as HPA and DCO, which is host protected area and device configuration overlay. We cannot access these two areas of HSD disk via OS or any BIOS system. It's a hidden area of HSD where we can store a lot of crucial information, and it's not easily accessible using any OS to any user or person trying to get in. For accessing this parts, to we need to use any tool. Like we can use disk checkout tool, Vista, and tabs. Have you wondered have you heard that a disk got corrupted or it's a non-bootable disk? Anyone?
Maybe bootable one.
Have you heard that this disk cannot be booted now or it's corrupted?
I'm not sure exactly.
Aryan, can you speak a bit loud?
I'm not sure exactly.
Okay. So if a disk is non-bootable or got some errors or got corrupted, we can use a tool called disk checkup. It not only helps us to access this host protected area and device configuration overlay, but it also decorrupts the disk. And if the disk is non-bootable, this tool makes it bootable and we can easily boot it. So talking about practical part, we would be performing on learning how to use autopsy. That's famous for doing a non-volatile memory analysis and capturing data. So this is the interface when we turn on autopsy. It's an open source tool and we can get it for free of cost from internet. So I'm gonna create a new case right now. So I'm just gonna click on new case. Then I have to enter the case name. So for example, I can enter 12 and I have to select the case directory where this case files will be stored. So it's in user admin documents and case type is single user. So after clicking on next, it will ask me like what is the number of the case, and I can just give it as one, the name as 12, and I can fill the details. It's not compulsory to fill the details, but if you want, you can. And we prefer filling it because while we are investigating cases, we get to know like what is the case number, the name of the case, phone numbers, emails, and other things. After clicking on finish, it will create a database and a setup for me to perform a non-volatile memory analysis. So once it's done, it will ask me like what type of forensics I have to do. Like, is it a disk image or VM file, local disk, logical files, and all allocated spaces, image file, logical image results, and XR via text report. So I will be selecting local disk and I have to select like which disk I have to do. So I can just refresh. If there is any external disk that I'm connecting, that will come over here. So I can just click on the disk and click on OK. Then I can select for FAT files, any VD image file that I want, and I can give the location of that file. And we can select the size of the sector that we need, like 5121024. And after doing everything, we can just click on next. And after a couple of minutes, it will give us, depending on the size of the disk file that we are providing to capture and recover data, it will give us the result over here. So I'm not going to perform anything live by selecting any disk right now because of time constraint, but you all can do that. Talking about non-volatile memory analysis, I would be using a tool called FTK Imager. So while we are performing a volatile memory analysis, we need to capture the RAM and dump it using a external drive. Usually prefer doing it with pen drive. So I have this application already installed in my pen drive, and I've already installed it in my machine too. So after installation of this is the interface that we want to get. And after going on file, I can add evidence. I can add all the attached files. I can capture my memory. So right now I'm going to capture my memory for this machine. So I need to specify the part like where it needs to go. So I'm going to go in my external drive and RAM. After doing that, I can include a page file and create an ADI file too. So after doing that, I can just click capture and it will dump all ongoing activities in RAM. So after dumping the RAM, we can actually analyze it using other tools and when we perform any forensics, we usually prefer to do it using a pair of tools. Just depend on either of the tools like only FTK Imager, Magnet, or any other tool. You need to keep capture it using various tools because all tools are different and are better than each other and have some speciality to it. So I'm right now gonna cancel it because it's gonna take some time to capture the RAM because it will be capturing RAM of page file too. How many of you have heard about OSINT? Anybody would like to answer?
Yes, me.
Yeah, Vaibhav, you can answer. Vaibhav,
Yes, yes.
you can answer. Like, what do you know about OSINT?
सेंट इज ओपन सोर्स इंटेलिजेंस टूल मतलब है सिंपल जो भी ओपन सोर्स में इंफॉर्मेशन होती है वो उसको एक साथ गैदर करके वो उनको प्रोवाइड करा देता है जितने भी मतलब इंफॉर्मेशन है जो कि पब्लिकली अवेलेबल है तो सारे इंफॉर्मेशन
Okay. So open source intelligence is a framework that we use to gather information that's available publicly on in public records. For that, we have a couple of frameworks that we need to look in. And the process of forcing is a five-step process. We need to identify the source. After identifying the source, we need to harvest the data on public sources and search engines. After we harvest all the data and gather all the data, we need to process and verify that. After verifying the data, we need to analyze it with our records and we need to match it. If it matches, then it's good. If not, then we need to see like what's there that's not matching and why. Like what's the reason for the same. After analyzing the data, we need to make a report and we have to deliver the results. So for OSINT, we have osintframework.com. You can use this framework to gather a lot of information using OSINT tools like username search engines, specified sites we can search on for. We can search for social networks. We can search for archives. We can use this framework to gather a lot of information about any specific organization or a person that's available publicly in data public records. A special thing about OSINT is that the site we are using today might not work tomorrow. So we can't completely depend upon OSINT sites because it's an open source framework and mostly there is no activity that takes place regularly on these frameworks. Along with OSINT framework, we also have one more framework that we can use. It's OSINT dot link. In this framework has a lot of tools preserved in it, and we can use this search engines and tools to gather a lot of information that's available publicly. Anybody knows like what are the myths that are there for OSINT? Here are some basic myths about OSINT. So let's say like what OSINT is not. Firstly, Googling is not OSINT. Using Facebook and Twitter searches is not OSINT. It's not easy as you think, and it's not a magic wand to identify every criminal and every crime that's taking place. OSINT is not complete information that we get. And last but not the least, the most important thing that people think is not true is you are not invisible while using OSINT tools. We leave our traces back while we use OSINT tools like our IP logs,